We've found and worked with growers across the country and abroad to elicit profound plant responses when following the apical method of crop improvement. There's a consistent pattern that has emerged within our data sets that we can respond to in real time. By analyzing properly through our methods the soil, leaf, and water, we can make some really good educated guesses about how to fertilize and how to adjust fertilization programs to achieve the outcomes that I just went over in the presentation here today. But it's bigger than that. When you start to take a look at the sum total of what we're dealing with, we are dealing with a element, carbon, that has been forgotten in commercial agricultural systems as needed by plants. There's a significant agreement that they're needed by soils, but they're not necessarily thought of as needed by plants. And by omitting that, we've been trapped in a 70-year cycle that's giving us depleting and diminishing returns to our country and our population. We now have the skills and the abilities to remediate and regenerate our land, our crops, and our population through these processes. I'm extremely proud of what our team here at Apical has uncovered and what we've achieved working with our manufacturing partners that we work with on a day-to-day basis across the country and abroad. Some of the growers that we've worked with, we're hoping to bring on to the webinars in later episodes to help them share their responses and their experiences. For those of you at home that have never heard of us or don't know me, I'd encourage you to start small and just try a few analysis and see where it leads you. It's pretty common that growers that use our system have profound plant response in a positive direction. We're here as a team to help guide you through from wherever you are today in your growing process to a better outcome. We care deeply about soils, plants, and the food that's grown in those environments. And we care about the longevity of the farmer's economic operations and viability. This is in everything that we do here at Apical, from the way that we process the samples to the way that we communicate with our customers. We consistently try to encourage positive behaviors and help you to figure out a better way forward. So with that, I will say thank you very much. It's been an extreme pleasure of mine to be here for these 10 weeks. We'll open it up for one final round of questions and look forward to seeing you in future episodes down the road. Thank you very much. Okay, so you see a first question here. Give me a second. Okay, so with the added complexity of deluxe level tests, what data analysis do you provide as part of the test? Does one need to have a corresponding soil test to be able to decipher the information? The answer is no, you don't need to have a corresponding soil test, although it can help. We offer detailed recommendations, one-on-one video conferences, on-site visits. We have a reading room with over 50 articles pertaining to critical topics. There's sampling guides, there's interpretation guides all over our website. We use target ranges, we use detailed comparison analysis reports, and we have an online data portal that allows you to compare and contrast your reports with one another. These are all resources that you can use to help you figure out the implications of the test and how they can be used to help improve your crop. I hope that answers your question. This next question, why is the sulfur to nitrogen ratio so important? Aren't they both uptaken at the same way in the plant, used for many of the same purposes, and complement each other? In the past, farmers used to count sulfur as part of their nitrogen applied. I do believe there is a proper balance. But I think I may be missing something to see it with the same importance as you do. So, okay, so oftentimes conventional nitrogen sources, so ammonium sulfate being a key one and its variants, or calcium thiosulfate, gypsum applications, just overall elemental sulfur applications, sulfur burners, micronutrient sulfate micronutrients in organic systems. These are all sources of sulfur that we see being put out. Sulfur is good, generally speaking. But when the sulfur level continues to be applied beyond the plant's ability to uptake it, you see long-term buildup in the soil environment, and then that interferes with protein metabolism in the plant's vascular system. We see massive problems with sulfur excess interference in wheat crops and small grains. We also see sulfur interference in fruit crops for sugar development as well. Sulfur is not necessarily, it is complementary to nitrogen, absolutely. But if you have too much, then your scales will be tipped in one direction. And we don't necessarily see it as a short-term situation. We see it more as a situation that has a long-term buildup that happens over years through consistent application and the plant's inability to continually metabolize the sulfur. In other words, the sulfur fertilization gets put out, the plant takes the calcium and leaves the sulfur. It takes the ammonium and leaves the sulfur. It takes the manganese or the iron and it leaves the sulfur behind. And so you have a consistent buildup of sulfur over time. Correspondingly, then we see nitrogen necessity increasing over time. There's a proper ratio on Albrecht mineral balancing that somewhere around 10 to 1, depending on the test, of sulfur to nitrogen. If you email us directly, we can elicit some of those direct ratios. They're kind of crop and soil environment specific, so it's not as easy to make generalizations. So in other words, there's a real difference in the sulfur content of sandy soils versus the sulfur content of clay soils, and it's a lot easier to build up soil to excessive levels in sandy soils than clay soils. So I hope that answered your question. Essentially, it's about balance, and as the plant has too much sulfur, it requires more nitrogen to balance that out. I'll add that that's a general theme with increased fertilization rates over time. So, in other words, if you're finding that you're continually applying more and more of a particular fertilizer year over year, I would encourage you to look at other elements within the system that are potentially being imbalanced or causing imbalance. If the ratios are, if the ratio of sodium to calcium starts to go really haywire, maybe you've got a sodium in the water, or maybe there's chloride in the water, or something like that. Carbon is king. Thanks again very much, and look forward to seeing you all next week. Take care.